we go. So we have 14.2 inverses in solving trigonometric equations. You'll need to follow me, I don't think, but it's okay. Okay. What's an inverse? Or why do we have inverse trig equations? Claire?
So find the angle of the, of the sine, cosine, or tangent.
Good, so if we have a trig value, we're going to be able to use an inverse to find what the angle is. For example, if we have the inverse sine of 1/2, what would that equal? Kenya. Good, this is going to equal 30 degrees. Okay, we can also say that this equals pi over 6. Now, one thing you got to make sure that you're distinguishing between is that if I have the inverse sine of, say, some value, say x, this does not equal 1 over the sine of x. Okay, that's important. The -1 raised right there, it's not a power, it just means inverse. So that's important that you understand that right there. Now, if I look at my calculator, which I'm going to break out right now, I can do inverses. Okay, if you look right here, I have inverse sine, inverse cosine, inverse tangent. You'll notice that if I do the inverse sine of, say, let's instead of doing 1/2, we'll do √3 over 2. Actually, let me check my mode real quick. Okay, I'm in degree mode, so we'll work with degrees, which is fine. But if I do the inverse sine, and let's do, like I said, √3 over 2. Okay, as you can imagine, I'm going to get 60. Okay, now, if I were to do the inverse sine of, let's go, -√3, I'm going to get -60. All right, and there's going to be a reason for that. Does anyone know why, if I do the inverse sine of √3 over 2, I get 60? But if I do the inverse sine of -√3 over 2, I get -60? Any ideas? Junior?
Because -60 is in the fourth quadrant. And
Okay.
It's negative in sign.
Alright, well why wouldn't they give me 300 versus -60? Because is -60 degrees the same thing as 300 degrees? It's coterminal, right? How come they give it to me as -60 instead of 300 degrees? Let me take this one step further. If I do this, if I do the inverse cosine of -1/2, okay, that gives me 120. Okay, it doesn't give me a negative value. And you're right about the quadrants. In the second quadrant, cosine's negative. So that's why we have it negative there. But I'm going to determine or show you guys why the calculator views the inverse sine of -√3 over 2 as -60. If you look at the graph of sine, and I'll just do a very kind of brief sketch here. We have y equals sine of x. And I'll do it with degrees. Okay, so this is going to be 180 degrees. This is 90, 270. This is 360. And if I were to keep going here, okay, I'm going to look like that, where this is going to be -90, and so on. Do you remember the horizontal line test? What was the horizontal line test? Tim?
If you make a horizontal line and it intersects more than one part of the graph, then the inverse of the function is not a function.
Good. So would you say the inverse of this is a function or not a function?
It's not.
It's not a function, because if I draw a horizontal line through here, notice I'm going to hit the graph in numerous spots, which means it doesn't pass the horizontal line test. Now, if I just take part of this graph, I can pass the horizontal line test. Okay, if I just take from here to here, do I pass the horizontal line test? I do, correct. So if I go anywhere past this X right here, past 90 degrees, I'm failing because I'm gonna cross it here and here. If I go anywhere past negative 90, I'm failing because I'm gonna hit here and here. So when we take the inverse sine of something, our values are always gonna be between negative 90 and 90. If I look at the graph of cosine, my cosine is going to start up top, so we're just going to look something like that, where we have, this is going to be, here's 180, I keep going, here's 360. If you look at cosine, if I wanted to figure out where it's going to pass the horizontal line test, I'm going to go from 0 to 180. Okay, if I go beyond 180, I'm failing. If I go to the left here of 0, I'm failing. Okay, so when I take the inverse cosine of something, my answer is always going to be between 0 and 180, versus for sine, it was between negative 90 and 90. What would happen with tangent? You might have to draw it out here. Sean, check the calculator.
Yeah.
That'll work. What's going to happen with tangent? Any ideas? Well, if I graph tangent, where are my asymptotes? Just y equals tangent x. You guys should know this. We did a quiz on this the other day. Virginia.
Pi over 2 and negative pi over 2.
Okay, so we have asymptotes here at pi over 2. We have asymptotes at negative pi over 2. And my graph looks, and this will just be a quick sketch of it, it looks something like this. What would happen if I drew another cycle? Lester?
You need another asymptote.
I would need another asymptote, but if I drew another cycle, would I pass the horizontal line test?
No.
No. So for tangent, if I'm finding the tangent, or if I'm finding the inverse tangent, my value is going to be, or my angle is going to be between negative pi over 2 and pi over 2. Or because we've been working with degrees, between negative 90 and 90. I'll write both right here. So negative 90 to 90, or, as you guys should know, negative pi over 2 to pi over 2. And so that's why the calculator is going to give you those answers, negative 60 degrees versus 300 degrees. Okay. Another thing to notice about when you're taking the inverse, at least sine or cosine, what happens if I do this? The inverse sine of 1.2. Someone do it in the calculator. Sean?
Error.
Error. Why would it be an error? Sean, why do you think it's an error? We go, hi, Young.
Because when you think of it, it's 12 over 10, and like
Yeah.
the 10 will be horizontal line, which means like horizontal line oh my god, wait, I'm sorry, the hypotenuse,
Hypotenuse?
yeah, hypotenuse cannot be like shorter than the other two lines.
Okay, that'll work. What do you say, Sean?
I was just going to say the opposite can't be longer than hypotenuse, so it's going to be less than 1.
Right, that'll work. Or anytime we take the sine or cosine of an angle, we're always going to be between here and here, which is between 1 and negative 1. So we can't take the inverse sine of something that's greater than 1 or less than negative 1. Okay, we can take the inverse sine of 1 and negative 1, but nothing that's less than negative 1 or greater than 1. Okay, that's an important idea. And when we solve trig equations, that's going to happen. We're going to end up getting some answers that will not work with our equation. Any questions so far? Ken, doing all right? Okay. Now, in the book, what's going to happen here is they're going to say, and this will be in your homework, and I would rather, if we're looking at inverses, just find the one angle. Because I like knowing this idea that you need to know for cosine is between 0 and 180, for sine is between negative 90 and 90, for tangent negative 90 and 90. And also the same thing goes for, if for cosine our inverse is between 0 and 180, the same goes for the secant. Okay, so the reciprocal trig functions are going to match with the function that they're the reciprocal of. So secant's going to go with cosine, cosecant will go with sine, cotangent will go with tangent. Okay, but what the book will ask you, and in your homework tonight will ask you, it's going to say find all angles who have a sine of, and it will give you some value. So for example, if we have the inverse sine of 1/2, okay, as we said before, and I'm going to do this in degrees and radians, the inverse sine of 1/2 is going to be pi over 6 or 30 degrees. But if I asked you find all angles whose sine is 1/2, there's more than just 30 degrees or pi over 6. Okay, what other angles would have a sine of 1/2? Just think about your unit circle. Lester? Well, we got 30 already. What other angle will have a sine of 1/2? Tori?
Is it 150?
150. Okay, so 150 would work. Or what's 150 in radians?
5 pi over 6.
Okay, good. What other angles would work? Will?
390,
390, okay, or
all coterminal angles.
basically all coterminal angles. So what angles have a sine of 1/2? We can say that this equals pi over 6 plus, and we can say 2 pi n, which pretty much means all angles coterminal to pi over 6. Or we can say 5 pi over 6 plus 2 pi n, which would give me all angles coterminal to 5 pi over 6. All right, and the reason why this is important is when we solve equations, you're going to solve it on an interval. So we're not going to have just one solution for a lot of these equations. We're going to have numerous angles that will make the equations true. Okay? Now, with the angles on the unit circle, I'm going to want you to use it, be able to find the inverse of them without a calculator. Okay, so some examples that you would see where you should be able to get without a calculator would be, and I have a bunch written up here. So something like, and I'm going to write 6 up, and I'm going to call on people here. We'll start with those 3. So these ones you should be able to get without a calculator. What's the inverse sine of negative root 3 over 2? We're just finding the one angle for right now.
60.
Okay, 60?
Negative 60.
All right, this is going to equal negative 60. Or negative 5 over 3. What's the inverse cosine of 1? 0 degrees or radians. What's the inverse tangent of root 3? Sean Shin.